Welcome back, and we're going to take a look now at question number 17 in lesson U1A7, applications of vectors. So in this question, we have to find the work done by a force of 30 newtons acting in the direction of the vector with coordinates -2, 1, 5. Now this force is moving the object from point A with coordinates 2, 1, 5 to point B, 3, -1, 2, and the distance is in meters, which tells us that all these numbers in here will represent meters. We need to know what the work is done, which means that we're starting with the work formula. So we know that work is given as the dot product of force and displacement. So to find the dot product of force and displacement, as you can see here, we have the algebraic product of the two vectors, which means we need to express both force and displacement in vector form. So we're going to start off with the force. All we know about it is that the magnitude is 30 newtons, and very importantly, the direction of it will follow the direction of vector u. Now recall that here we are in 3D, and if you want to define the direction of a vector in 3D, we have to use the three angles that the vector will make with the respective axis. So in other words, if you remember, we have used what we call the direction cosines. So the direction cosines for vector u and vector f, since they are going in the same direction, will be the same. It is more convenient for us to find the direction cosines for vector u because we know all three coordinates. So remember that direction cosines will give the angle alpha, angle made with the x-axis, as x over the magnitude of the vector, and cos beta will be y over the magnitude of the vector, and then cos gamma as z over the magnitude of the vector. So we need to get started with finding the magnitude of vector u. Vector u with coordinates -2, 1, 5 will have the magnitude equal to, I know when this happens, -2 squared plus 1 squared plus 5 squared. So that would equal the square root of 30. So we'll say that for vector u, we will have the direction cosine alpha equal to x, which is -2, divided by the magnitude, which is root 30. Cos beta, which is going to be the angle made with the y-axis, will be the y-coordinate over the magnitude root 30. So that will make it 1 over root 30. And cos gamma, which is the angle made with the z-axis, will be the z-coordinate over the magnitude, which is the root 30. So 5 over root 30. Now remember that if two vectors go in the same direction, their direction cosines must be the same. So now let's talk about the force F. If we knew the coordinates of force F, then you would say that cosine alpha must have been the x-coordinate, which we don't know yet, over the magnitude of F, which is 30 newtons. Cos beta, on the other hand, would have been y, which we don't know yet, over the magnitude of force F, which is 30. And cos gamma equals some coordinate z, which again we don't know yet, over 30. So now, when we look at the direction cosines for vectors u and f, remember that they go in the same direction, right? Then we're going to say that the respective direction cosines must be equal. So we're talking about the same angle alpha made with the x-axis. So therefore, or this will allow us to state that -2 over root 30 would equal x over 30. Similarly, 1 over root 30 equals y over 30. And last but not least, we have 5 over root 30 equals z over 30. So we're going to solve for each coordinate. Remember, x, y, and z now will give the coordinates of vector f. So cross multiplication everywhere to solve for the unknown variable. And here we go. We have x equals -60 divided by root 30. y will be 30 times 1, 30 divided by root 30. And z will be 30 times 5, 150 divided by square root of 30. So therefore, we're going to say that the coordinates of vector f are negative 60 root 30 over root 30, 30 over square root 30, and 150 over root 30. You can simplify as well or reduce to lowest terms possible. So I'm going to move on to finding the displacement, and I will simplify the answer at the end. So the displacement vector, since we're going from A to B, it means that A must be the tail and B must be the head of the vector. So to find the vector AB, we are subtracting 3 minus 2. So x of B minus x of A. So we'll say that the displacement vector will be vector AB. So that would equal 3 minus 2, that's 1. And then 1 minus 1, that's the y coordinates. And then for z, 2 minus 5. So 1 minus 1 and 2 minus 5. Okay, so here we go. We have finally found the coordinates of the displacement as 1, 0, and negative 3. These are nicer numbers. And we're ready to multiply force with displacement. And we're going to say that force dot displacement will give the work done on the object, and that would be negative 60 root 30, 30 root 30, 150 over square root 30, multiplying 1, 0, and negative 3. So again, x and x will go together, the y's will go together, and the z's will go together. So that will give the work equal to negative 60 over square root of 30. So these two multiply. Now, root 30, 30 over root 30 times 0, that would be 0. And last, 150 over root 30 times negative 3. So negative 450 over square root of 30. So the work would equal negative 450 minus 60, that's negative 510 over square root of 30 Newton meters or joules. And this is the final answer. So I hope this made sense, and I hope you found this useful. Bye for now.